2009, number 5, again, no TI. Okay, so all I have to work with is this chart. Part A, estimate f prime of 4 and show the work that leads to your answer. In this case, the derivative is the slope of the tangent line. All I have are these points here that were given to me in the table. So if I'm going to estimate the derivative, that means I'm estimating a slope. I cannot find the exact derivative. Therefore, I'm going to find the slope of the secant line because that's what we use to estimate derivatives. In this case, since I want the derivative at 4, I'm going to find the slope of the secant between 3 and 5. So the work here is pretty straightforward. F prime of 4 is approximately slope of the secant, use my y values, -3. And you're done with part A. Part B, evaluate this integral and show the work. Okay. So this one is a little more, it's just plugging in numbers, evaluating your integral. It's not horrible. If you look at this, for part B, and I did it 2 different ways, I think this is the easiest way. When I look at my integral, I'm going to split the integral. So I'm going to integrate 3 from 2 to 13 minus the integral, and then 5 is a constant, so I just pulled that out in front, the integral of f prime of x. Now when I integrate 3, I get 3x, upper limit minus lower limit. That's pretty straightforward. Minus 5 times, and then if you look right here, it's when I integrate f prime, I get f of x, upper limit and lower limit. So I get 5 times, plug in my upper limit minus my lower limit. So over here, 3 times 13 is 39, 3 times 2 is 6, so that's my upper limit minus lower limit for this part of the integral, minus 5 times f of 13, I'm just reading that off of the table, and I get 6. F of 2 from my table is 1. And I just evaluate all of that, and I get 8 for a final answer. Not too bad, okay? Part C, use a left Riemann sub with some intervals indicated by the data to approximate this. So here we go. I'm using Riemann sums. I like a graph. I want to plot this and kind of take a look at things. So what I did is I kind of plotted out the points that were given to me. Left end Riemann sums means I'm starting on the left side of the triangle, and that's where I get the height from the triangle. Left side of a triangle, and that's where the height comes from. I'm getting it from the left side. I'm sorry, not triangles, rectangles. So left side and over, and so I get all my points. I plot it out. I find the area of each rectangle. This rectangle right here, since it's below the x-axis, that's a -6. Find the area the same way. Base is 3, the height is 2, so that, because it's below, is -6, and that's it. That's your approximation right there, okay? Part D. This is a little trickier, so this is where I kind of think it's going to help if I show you all my work for this one. They're telling me that for part D, that f prime of 5 is 3, and f double prime of x is less than 0. What you need to realize, no, I'm going to hold off on that thought. And I have my closed interval from 5 to 8. Use the line tangent to the graph at 5 to show that f of 7 is less than or equal to 4. I don't really know what they want to show me at this point, but I'm using the tangent line at 5. So here we go. Y minus f of 5 equals f prime of 5 times x minus 5. So let's just see what happens. Y minus, well, f of 5 is -2, so plus 2 equals, this was given to me, 3 times x minus 5. Now, they're asking me about f of 7, and they want me to use my tangent line. So I'm going to sub in a 7. Y plus 2 equals 3 times 7 minus 5, and I end up with y is equal to 4. So now what they're saying is show that f of 7 has to be less than or equal to 4. Well, here's the key to this problem. The second derivative is negative. Therefore, my graph is concave down. If I have a graph that's concave down, and I find the equation of the tangent line, okay, this is the equation of the tangent line at 5. Right over here, if I move to the right, that's when x is 7. The tangent line says that the y value will be 4. Therefore, the actual y value has to be less than 4. So I've just proven that because it's concave down, let's see here, f of x is concave down, f of 7 has to be less than or equal to 4, okay? So now they're asking me to do something very similar, only I'm using the secant line from 5 to 8. So that means I'm using the coordinates 5, -2, and 8, 3. I need to find the slope of the secant line, which is 3 minus -2 over 8 minus 5. So I get 5/3. Pick a point, write the equation. Y plus 2 equals 5/3 times x minus 5. And they want me to evaluate when x is 7. So when I sub in 7, I get this, and I solve that. Distribute, you get 10/3 minus 2, you get y equals 4/3. Now, if you think about this, I have a function that is concave down from 5 to 8. So what I just did, it's concave down from 5 to 8. I just found the equation of the secant line. On the secant line, if x is 7, y is 4/3. Because my function is concave down, the actual value of f of 7 has to be greater than or equal to 4/3 because the actual value of f of 7 is up here on the curve. So therefore, f of 7 has to be greater than or equal to 4/3 because f of x is concave down again. And you're all set with that one.